Right now, somewhere online, a headline is telling you NASA can't explain what 3I Atlas actually is, as if America's entire space agency is standing around baffled, refusing to comment, hiding something it doesn't understand. Here's the truth. Nobody wants to slow down and tell you. NASA has an explanation. A detailed, published, peer-reviewed one. What NASA didn't have, for a very specific and very documented stretch of time, was the willingness to actually show you the pictures it already had. And that gap between what the agency knew and what the agency was releasing is exactly the space China's own space program stepped into first. Because this isn't really a story about aliens, even though it's been dragged there more than once by people with very large platforms. It's a story about a genuinely rare visitor from outside our solar system, an object almost certainly older than the sun itself, caught on camera by 3 different countries' space programs within weeks of each other, arriving at a moment when one of those countries had gone quiet at exactly the wrong time to keep the public's trust. And once you understand what actually happened and what scientists have actually found sitting inside this thing's chemistry, you'll understand exactly why this story refuses to die down. This is the real story of 3I Atlas, the 3rd confirmed interstellar object to ever pass through our solar system, the international scramble to photograph it, and the very real, very unresolved anomalies that even mainstream scientists admit they can't fully explain yet, even while insisting loudly that none of it points to anything artificial. Start with what 3I Atlas actually is, because the name itself tells you almost everything about how it was found. On July 1st, 2025, the NASA-funded Atlas Survey Telescope, based in Rio Hurtado, Chile, an automated system built specifically to scan the sky night after night, looking for anything moving in a way normal solar system objects don't, picked up a faint object tracking across the sky on a trajectory that made astronomers' pulses jump the moment they ran the numbers. Its path wasn't a closed loop, the kind every planet, asteroid, and comet native to our solar system follows around the sun. It was hyperbolic, a trajectory so fast and so open-ended that the object could only have arrived from somewhere else entirely, out past the edge of our solar system, born around a different star, flung loose sometime in that star system's history, and drifting alone. Through interstellar space for what astronomers now estimate has likely been millions, possibly billions, of years before it ever crossed paths with our sun. It's only the 3rd object of its kind ever confirmed, following Oumuamua in 2017, a strange, elongated visitor that sparked its own alien controversy years before this one, and 2I Borisov in 2019, a far more conventional-looking interstellar comet that behaved almost exactly the way scientists expected. 3I Atlas immediately stood apart from both. Early estimates suggested it might be significantly larger than either of its predecessors, with some size calculations comparing its nucleus to something roughly the length of Manhattan Island, an object big enough and moving fast enough that space agencies around the world started rearranging their observation schedules almost overnight to get eyes on it while they still could. Every major instrument capable of looking got pointed at it in some form. Hubble helped pin down its size. The James Webb Space Telescope captured detailed chemical fingerprints of the gas surrounding its nucleus. NASA's Sphere-X observatory collected roughly a week's worth of data on it. Even spacecraft that happened to already be in the right part of the solar system got pulled into the effort almost by accident. The Psyche spacecraft, on its way to study a metallic asteroid, grabbed 4 separate observations over 8 hours. The Lucy spacecraft, en route to the Trojan asteroids near Jupiter, spotted it from nearly 240 million miles away. It became, within a matter of weeks, one of the most closely watched objects in the history of solar system astronomy. An interstellar visitor that happened to be passing close enough at exactly the right moment for practically every telescope humanity had in position to actually catch a piece of it. Then, in early October 2025, as 3I assumed Atlas swept close to Mars on its way toward the Sun, exactly the kind of close planetary flyby that gives spacecraft already in orbit a rare. Nearly free opportunity to get a close-up look, things got complicated. NASA had assets in position. The Mars Reconnaissance Orbiter's high-resolution high-rise camera was scheduled to capture images during the object's closest approach on October 2nd, precisely the kind of high-resolution imagery scientists were desperate to see. And then, almost immediately afterward, those images simply didn't come out. A federal government shutdown had begun right around that same window, freezing large portions of NASA's public communications and slowing the agency's ability to process and release new data at the exact moment public interest in this object was reaching its peak. That silence didn't sit quietly. Astronomers, journalists, and space enthusiasts started publicly asking where NASA's Mars imagery had gone, and Harvard astrophysicist Avi Loeb, who had already become the loudest and most persistent voice pushing an alternative, deliberately provocative explanation for 3I Atlas began directly and publicly pressuring NASA to release what it had captured, arguing that the government shutdown shouldn't be allowed to sit on top of legitimate scientific data the public had every right to see. Into that exact gap, China's space program moved first. China's Tianwen-1 spacecraft, which had already been quietly orbiting Mars since 2021 as the country's first successful planetary exploration mission, used its own high-resolution camera to capture 3I Atlas between September 30th and October 3rd, imaging the object from roughly 29 million kilometers away as it swept past the red planet. China's National Space Administration published the results not as a rushed press release, but as a properly documented scientific observation, submitted for publication and eventually posted as a formal paper, complete with stacked imagery showing the comet's coma and tail-changing shape as the viewing geometry shifted across those few days. It was, by any honest measure, a legitimate, useful scientific contribution, giving researchers a genuinely unique vantage point on the object's dust dynamics from an angle no other observing platform had. But it also landed at a moment when NASA's own comparable imagery from the same event still hadn't surfaced publicly, which meant, for a stretch of time that stretched into weeks, the sharpest available pictures of humanity's third confirmed interstellar visitor, captured during its closest approach to another planet, were sitting in Chinese hands, while America's own space agency stayed quiet about images it was already known to have. NASA's imagery eventually did come out, once the shutdown ended and normal operations resumed, but the sequence of events had already done its damage to the narrative. China released it first, while NASA sat on its own pictures, isn't a conspiracy theory, it's a documented timeline. What that timeline does not prove, despite how often it gets stretched to imply otherwise, is that NASA was hiding something because it didn't understand what it was looking at. It was hiding something because a completely unrelated political funding fight had frozen its ability to publish anything at all. So what does NASA and the overwhelming majority of the scientists actually studying this object actually think 3I Atlas is? A comet. Not a metaphor, not a hedge, an actual, specific scientific classification, and one backed by a genuinely large body of consistent evidence. Its color, its speed, its trajectory, and critically, its behavior as it approached the sun, all lined up with what astronomers expect from a comet. An icy nucleus, heated by starlight, releasing gas and dust into a glowing coma and tail, as frozen material sublimates directly from solid to gas. Webb's spectroscopy detected carbon dioxide, water, and, in a first for any interstellar object ever observed, direct evidence of methane streaming off its surface. Separate analysis found unusually high levels of carbon dioxide relative to water for an object this active, and later, observations picked up something scientists hadn't expected either. 3I Atlas turned out to be releasing far more water than its apparent size should allow, essentially spraying it across the solar system as it warmed. Evidence researchers now believe points to an object that formed somewhere unusually cold, likely far colder than anything that shaped the comets native to our own solar system. Even its age tells a striking story on its own. Analysis of its composition and trajectory suggests 3I Atlas may be older than our entire solar system. A genuine multi-billion-year-old fragment from the early galaxy, potentially the oldest comet humanity has ever directly studied up close. That's the mainstream picture, and it's genuinely fascinating entirely on its own merits. No aliens required. But it's not the whole picture, and pretending the anomalies don't exist would be its own kind of dishonesty, because several of them are real, published, and still not fully explained, even by scientists who are completely convinced this is a natural object. The one that gets repeated most is the nickel. Spectroscopic analysis of 3I Atlas's gas plume detected nickel emissions without a corresponding expected signature of iron alongside it, an imbalance that doesn't match the ratio typically seen in comets from our own solar system, where nickel and iron usually show up together in fairly predictable proportions. Loeb has pointed directly at that imbalance as potentially resembling the specific carbonyl chemical pathway used in industrial nickel alloy manufacturing here on Earth, framing it as a possible technological signature. Most planetary scientists studying the object take the anomaly seriously as something genuinely unusual and worth investigating, while pointing out that unfamiliar nickel-to-iron chemistry is exactly the kind of surprise you'd expect from an object that formed in a completely different part of the galaxy, under different conditions, around a different star, rather than evidence of manufacturing. Then there's the object's color and brightness. As 3I Atlas approached its closest point to the sun, instruments recorded it appearing distinctly bluer than sunlight itself, a shift multiple observers described as genuinely surprising given its earlier reddish, then greenish appearance in the weeks before. Around that same close approach, the object also brightened rapidly, and the separate measurements picked up what scientists call extreme negative polarization in the light scattering off it, a pattern. Researchers say hasn't been recorded at that intensity in any previously studied comet, including 2I Borisov. Add to that a persistent detection of what's called non-gravitational acceleration, a measurable deviation from the path pure gravity alone would predict, and you get exactly the kind of dataset that fuels genuine scientific debate. The overwhelming consensus reading is that this acceleration is a completely ordinary cometary signature, the recoil force produced when a comet's own surface unevenly vents gas as it's heated, a well-documented phenomenon that's been measured on plenty of comets before, including Oumuamua itself back in 2017. Detailed modeling published in early 2026 using JPL's own orbital tracking data found the acceleration falls within, if toward the upper end of, the range already seen in actively outgassing comets, consistent with exactly that kind of natural recoil, rather than anything resembling propulsion. Loeb reads the same numbers differently, arguing publicly that the size of the deviation implies the object should have visibly lost 10 to 20% of its own mass through outgassing to produce that much recoil, an amount of visible material loss. He says the observations don't actually show, and he's floated the idea, deliberately framed as speculative, that an internal engine could theoretically produce a similar effect without matching mass loss. It's worth being direct about where that idea sits scientifically. It remains a minority position, actively disputed by the researchers doing the detailed orbital modeling, and it hasn't displaced the outgassing explanation as the scientific consensus. But it's also true that the measurement itself, the acceleration, the color shift, the nickel imbalance, the unusual water content, are documented, published, and not yet fully resolved down to a single, universally agreed upon mechanism, which is exactly the gap that makes room for competing interpretations to keep circulating. There's also the trajectory itself, which even skeptical scientists acknowledge is genuinely unusual in one specific respect. 3I Atlas arrived on a path aligned unusually close to the plane in which the planets orbit the Sun, and moving in a retrograde direction relative to their motion, a combination researchers have calculated is statistically uncommon for an object arriving randomly from interstellar space. Loeb has pointed to the object's close passes near Mars, and later near Jupiter as convenient positioning. Most working astronomers studying interstellar objects respond to that specific argument the same way. An unusual trajectory is still just one data point among an enormous number of possible random paths through the galaxy, and finding one visitor with a statistically uncommon angle isn't remotely the same. Thing is finding one with a controlled one. Here's the part of this story that deserves real weight, though, because it says something true about how science actually works, not just about this one object. Of the growing list of specific anomalies Loeb has compiled and expanded over the following months, other researchers directly studying the data have been candid that only a handful genuinely warrant serious follow-up. The nickel abundance, the extreme polarization, the unusual water content, and the rapid brightening near the Sun. Every one of those four is real, published, and currently sitting without a fully settled explanation. None of them, according to the overwhelming majority of scientists examining them, requires anything beyond natural comet. Physics, operating on a comet built from unfamiliar ingredients, formed under conditions our own solar system's comets never experienced. But unfamiliar and not yet fully explained is a genuinely different statement than NASA can't explain what it is, and conflating the two is exactly how a real, interesting scientific mystery gets flattened into a much less interesting alien headline. 3I Atlas made its closest approach to the Sun in late October 2025, swept past Mars in early October and is now already on its way back out, heading toward Jupiter and eventually leaving the solar system entirely, never to return, following the same one-way hyperbolic path that brought it in. Everything humanity has learned about it, its chemistry, its color, its trajectory, its age, has come from this single narrow window, weeks of observation squeezed out of an object that spent longer than human civilization has existed drifting silently through the space between stars before anyone on Earth ever pointed a telescope at it. To understand why an object like this generates this much noise in the first place, it helps to look back at what happened the last two times something like it showed up. In October 2017, astronomers spotted Oumuamua, the very first confirmed interstellar object, tumbling through the solar system on its own hyperbolic path. It was small, elongated, and, crucially, showed no visible coma or tail at all, none of the classic gas and dust glow that normally identifies a comet, even though it did display a faint non-gravitational acceleration as it left. That combination, an accelerating object with no visible outgassing to explain the push, is exactly what first pulled Avi Loeb into this entire conversation years before 3I Atlas ever existed. He co-authored a paper suggesting Oumuamua's motion could be explained by sunlight pressure on an extremely thin artificial structure, essentially proposing it might be a light sail, and the resulting media storm turned a Harvard astrophysics chair into arguably the most publicly recognizable and most publicly polarizing figure in the entire field. 2 years later, in 2019, 2I Borisov arrived and behaved almost boringly by comparison. A clearly active, gas-releasing comet nucleus that matched expectations closely enough that it barely generated any alien speculation at all. 3I Atlas landed in between those two precedents, active and clearly cometary like Borisov, but carrying enough specific chemical and behavioral quirks to reignite exactly the kind of debate Oumuamua started 8 years earlier, with Loeb, predictably, leading that charge again. That history matters because it explains why Loeb's claims get the reach they do, even when the majority of his own colleagues push back on them directly. It's not that nobody is checking his math. Multiple planetary scientists have published detailed rebuttals walking through his list of anomalies point by point, and the consensus among them is consistent. The vast majority of the items on his growing list, at one point stretching past 15 separate claimed anomalies, either fall well within the range of behavior already documented in known comets, or rest on measurements with wider uncertainties than his interpretation assumes. One of the more widely circulated claims, that 3I Atlas's arrival direction lined up suspiciously close to the origin point of the famous 1977 WOW signal, a brief, unexplained radio burst. Some have speculated might have been extraterrestrial in origin, drew particularly sharp criticism from other astronomers, who pointed out that with enough interstellar objects and enough historical radio anomalies to compare against, some coincidental alignment was always statistically likely to turn up eventually, whether or not it meant anything at all. Even the more sober version of this story, purely from a public trust standpoint, produced real friction. Reports also surfaced that NASA's own Planetary Defense Coordination Office, the section of the agency responsible for tracking objects that pass anywhere near Earth's orbit, formally logged and monitored 3I Atlas as a matter of standard procedure, the same way it tracks any sizable object moving through the inner solar system regardless of its origin. That routine, procedural tracking, got repackaged in some corners of the internet as evidence NASA was quietly treating the object as a potential threat, a framing agency scientists have consistently rejected, pointing out that 3I Atlas was never on a trajectory that brought it anywhere close to Earth itself, and that logging an unusual object's path is simply what the office exists to do for anything passing through, interstellar or not. What happens next matters just as much as anything already observed. 3I Atlas is a wondrous time visitor, gone for good once it crosses back out past Jupiter's orbit and continues on into interstellar space, never to loop back around the sun again. But it almost certainly won't be the last object like it. The Vera C. Rubin Observatory, a next-generation survey telescope that only recently began its full operational science campaign, is specifically built to scan enormous swaths of sky repeatedly, night after night, searching for exactly the kind of faint, fast-moving objects that Atlas caught somewhat by chance. Astronomers involved with the project have been public about their expectation that instruments like it should start finding interstellar visitors far more often than the roughly one every few years pace humanity has experienced so far, potentially turning what's currently a rare, headline-grabbing event into a semi-regular occurrence within the coming years. If that prediction holds, 3I Atlas won't be remembered as some singular, unexplainable mystery. It'll be remembered as the messy, contested, genuinely fascinating dress rehearsal for a version of astronomy where interstellar visitors stop being once-in-a-decade news and start being something scientists simply learn to expect. All of this unfolded against a backdrop of genuine public anxiety that went well beyond the usual audience of dedicated astronomy enthusiasts. Search interest in 3I Atlas spiked repeatedly throughout late 2025. Each time a new anomaly claim or a fresh round of imagery made headlines, and members of Congress reportedly asked NASA directly for briefings on the object. During the same period, the shutdown was delaying its own image releases, a collision of ordinary bureaucratic timing with a story that had, almost by accident, become one of the most talked about scientific events of the year. None of that public attention changed the underlying data. It just meant that a genuinely interesting, still partially unresolved question in planetary science got asked, argued over, and speculated about by a far larger audience than the handful of specialists who normally handle interstellar object research, for better and for worse. So here's the real story. Once you strip away the fake urgency and the manufactured alien panic and let the actual sequence of events sink in, China genuinely did get its images out. First, not through any secret advantage, but because a government shutdown froze NASA's own release schedule at precisely the wrong moment. NASA genuinely does have an explanation for what 3I Atlas is, backed by spectroscopy, orbital mechanics, and imagery from half a dozen different spacecraft scattered across the solar system. And several of the strangest details in that data genuinely haven't been fully nailed down yet, not because the answer is being hidden, but because this is only the third object of its kind humanity has ever gotten a close look at, and every single one of them has shown up carrying at least one detail nobody predicted in advance. 3. Atlas is already leaving, on a path that guarantees nobody on Earth will ever get another chance to look at it directly again. Whatever's still unresolved about it stays unresolved, at least until the next interstellar visitor happens to wander close enough for someone, somewhere, to notice it in time.